Sanchez. I'm an associate professor at the University of Michigan, Tubman College. It's a really great pleasure to have Casey Rehm joining us today. Casey Rehm is a multidisciplinary designer and founder and founding partner in the Ishida Rehm studio in Los Angeles, California. He teaches in the Southern California Institute of Architecture, SCI-Arc, where he's the coordinator of the Master of Science and Architectural Technology post-professional program. He received a B.Arch in Carnegie Mellon University in 2005 and his MSAAD from Columbia University in 2009. He has professional experience working in Los Angeles, New York, Berlin, London, on a range of projects from low-income residential to large cultural projects. Casey has been a colleague and a friend in the time I was in Los Angeles, so I'm happy to have it with us so that we can discuss his work and his approach towards computation and architecture. Thanks for joining us, Casey.
Thanks for having me, Jose. And thank you to the Architecture Informatics Society channel for the invitation as well.
Yeah, absolutely. So I want to start the interview by going a little bit back. I think you and I, coming from a similar kind of background in architecture and computation, there's been kind of a trajectory of using different tools, different algorithms, and different techniques to approach design. Can you take us a little bit back through how you have reached the current state of your work, perhaps considering some of the techniques and tools like, architectural intelligence in the form of swarms or cellular automatas that I know that back in the day we were both kind of looking into, and how has that taken you for where you are right now?
Yeah, sure. I mean, I don't have any slides going back that far, but my first interest in intelligent agent systems, multi-agent systems, was back in about 2003. There was an exhibition at the Wexner Center called Mood River that Jeffrey Kipnis curated, and actually a current colleague of mine, Marcin Gao, participated in the development of that, and he came and lectured at Carnegie Mellon while I was a student there. And one of the things he talked about was the organizing of these kind of design products based on this concept that he called panic. It's something that John Holland, the kind of godfather of complex adaptive systems, actually describes as drift, but it's the way in which kind of behaviors are passed through a population, and qualities can be passed through a population. So basically, coming from that lecture, this wasn't the type of work that was being pursued at Carnegie Mellon, and I kind of locked myself in a cage and started to work out how to begin to code these types of things. And I kept coming back to it over my career. And the thing that was really interesting to me about this was specifically that these are computational models that are inherently designed to provide like alternative or maybe in some cases improved understandings of complex external information. Like they're computer simulations that by their kind of structure are very adept at engaging external information from like outside the computer, which I think was a kind of break from a lot of the early digital simulation work, like the paperless studio work, or the work of Carl Chu in the kind of cellular automata world, where you're looking at the kind of simulation being this wholly complete internal thing that happens inside the computer, inside the black box of the machine, and then gets kind of dropped into the world and post-rationalized. And I actually think they're probably like the first few generations of, or the first generation of intelligent agent-based architects, people like Alyssa Andersek that you worked with, or Roland Snooks that I eventually worked with. There was this a bit of a holdover from kind of Carl's teachings and this idea of the kind of fully contained model, right? That then got propagated, like kind of simulating everything inside of there. And so basically, I think kind of my main break with that was immediately trying to look at how you could use the external world as a source of information, a source of intelligence that your machine and your simulations were constantly responding to or that kind of loop effect of percepts from the environment and then making decisions and feeding back into it. So I do a lot of experiments in image for that type of work, like things where I'll play around with in sometimes very kind of absurdist ways, like just playing around with a human tracker to just make videos of the city where the only thing that gets updated in the frame or where the humans are, like looking at how different layers of machine vision and perceptual systems can begin to create like new aesthetics. I did a project recently with Damien Ivanovic where we had this kind of real-time app running on Twitch for last year's Cyric Spring Show, which was due to COVID fully online. We're looking at how we could combine some self-organizing systems and logics within the simulation, neural net that was translating language inputs from Twitch into this kind of real-time, it's not really a game, but but it's kind of this game platform or modeling platform where people could begin to model these structures on Twitch in real time. So it's like there's always this idea that the machine is constantly engaging information that's coming in from the outside and trying to like reconstitute or build value on that for the production of the architecture. If that makes sense.
Right. I mean, I remember back in the time when we were studying, and also when some of this work started, that there was a lot of conversation of transcoding, of like taking certain data and converting it in a way using kind of different techniques for generative form. But it seems to me that the way you approach the production of value seems to go beyond that, right? It seems to kind of have a departure from a kind of a perhaps linear transcoding of data into a system, but rather kind of processing it further. Is that something that you?
Yeah, I mean, I do think that I tend to be suspicious of kind of linear parametric systems. I think all of the work we do, it tends to do with sorry, very early here. It tends to do with the things that are like some ideas that come from stuff that more recently, which is not things that I was reading when I started this, but like Ray Brassier's writing on kind of Promethean nihilism, and that kind of attitude towards data and the consuming of these things. Like one of the things that when you start to work with algorithms which are consuming data or receiving data, whether it's a LiDAR scanner, a web camera, or scraping social media sites, you start to kind of recognize how little value it has inherently. And so I see the kind of project of the designer then is to take this data and then generate some kind of value structure from it, like reconstitute what's valuable in it, what's important from it. And I think maybe back when we were talking about the different data structures I work with, there's been certain shifts in the processes that we work with over time. Like at one point, like the move to kind of voxel-based systems was done, I want to say like maybe 2014 or 15, and that was specifically as a way to create a kind of a domain for data and information where I could kind of flatten multiple inputs or multiple sources, multiple types of simulation into the same space. I think the work that tends to interest me with the neural net stuff, which is we started to think now maybe again that's probably back around 2016. It was around the same time we switched to the voxel specifically because we were interested in this kind of machine learning space, which came out of some of the project work that we're doing just on like an installation scale. An installation I did at Cyric called Control, which was just a kind of a bunch of sticks piled together. But even I can pull up a picture. Sorry, my PowerPoint crashed. Very technologically advanced to crash a PowerPoint. This installation that we built, which was kind of fully autonomous in its design process. It's built on an intelligent agent platform. It's mediating things like building codes, like spatial considerations. Like it's this kind of prototype living room scale thing, and then it also has kind of structural performance built into it. And the idea of like the explicit intelligent agents that we would write, the kind of GoFA, the good old fashioned AI, where you have to explicitly like write in every behavior for the system, we kind of quickly realized was a kind of absurd proposition for architecture. And so that was kind of the big push towards starting to engage in neural networks, because something that they do very well is, the big difference with those is you're not explicitly coding the behaviors, you're training them from example information, right? So it does a very good job of identifying relationships and behaviors across like multiple scales and hierarchy, which I think is something that's fairly difficult to do when you're explicitly writing, the logic and behavior for even like a small installation like this, right? Like this becomes a very heavy piece of code just to kind of mediate everything from the kind of budget information, the material costs and lengths and the structural performance, and then the joints, like what kind of joint do I need at this connection, which in this case is just a couple simple like anchors, on studs on the ground, and some rules about like where you can get an air gun and where you can't. The whole kind of idea of coding these things all explicitly becomes immediately absurd, especially when you start to think about scaling up to building like an actual like kind of full building scale.
Right, that's really interesting. I mean, do you think, just mentioning a little bit of what you've mentioned here, and I want to kind of go a little bit deeper on how this idea of perhaps at a certain point you mentioned you were working with voxels to flatten the domain of this external data, right? Do you see, and I feel like I kind of understand that is kind of both a great opportunity, right? But at the same time, I imagine that there might be some missing information, something that might escape the data structure. Do you find yourself in a situation where let's say the regime of data structure that you're using kind of is capable of a lot due to the resolution as well, but perhaps has to kind of call or get rid of some of the information that is coming from these external sources?
Yeah, absolutely. I mean, I think moving forward too, within the profession and the discipline, like this needs to become a central part or a central idea of like what authorship is in architecture. Like as we start to work more and more with platforms which can automate many of the architectural tasks that are a lot of them built off of these feed forward networks or feed forward learning, right, from external data. The act of designing how architecture is represented to machines is, I think, a critical point of authorship that needs to be considered. So you absolutely are losing things, and it's part of the design process to construct why, where the shortcomings are in losing that information, what needs to be kept and what doesn't. There's no such thing as this kind of objective, omniscient machine, right? Like all of them have their own kind of internal biases, and so operating with them without being cognizant of them is, I think, a failing on the part of the designer.
Right. And do you see the process of producing the data sets, the training information, as something that is fundamentally also linked to this authorship, I imagine, right? Or do you think that there is potentially some kind of further collaboration? In a way, it seems like in machine learning, there seems to be so many initiatives to produce data sets that are purposeful for a large range of scientists, right? But it seems like when you're talking about it through the lens of authorship, the curation of a particular data set seems critical to the kind of performance of the algorithm, right?
Yeah, I mean, I think a good example of that, like when we did it as a kind of a joke, I mean, a couple of years ago when you and I were presenting on a panel together, like I think like even these attempts to build all-encompassing data sets like fell. Like those are just 200 faces, but in the office we did a quick image classifier by scraping LinkedIn of like architects and non-architects heads, right? To then try to predict if someone was an architect or not. And you can see that an example here, right? Like you're performing very poorly in this image classifier. And that's because on LinkedIn, even if like those were 200 faces, we scraped 10,000. architect headshots. The South American features or Latin American features, or just that ethnicity is underrepresented in the current profession of architecture, right? Like there's just fewer people in the United States from that ethnic background that are in the profession. So, even if you're trying to do this like bulk scrape, you also have to recognize that any of the data that you're using is basically reinforcing pre-existing inequalities. And that's something that you have to be cognizant of. I think one of the big traps with neural networks and feed-forward networks that you have to be aware of when you're working with them is that they're very good at automating existing solutions to problems, right? And that the real trick to use them generatively or find new solutions with them is either to utilize them to recontextualize information in a way to undermine your own biases or challenge your own biases, or try to be cognizant of their biases and where they need to be modified or interjected against with other forms of intelligence, either like human collective behavior, individual behavior, or a specific code developed by the author.
Right. Yeah. Absolutely. It might be that also. Yeah. No, I think that you're right in how it's interesting how one has to kind of double guess some of the current information that is presented on something like LinkedIn as well, like all the kind of protocols that might be already at play.
Mm-hmm. We do a lot of work with floor plans, right? And building spatial organization program. And what you realize very quickly is the machine will do an exceptional job at reproducing the types of floor plans we've already seen. But that means it kind of prohibits it from actually generating new ideas about spatial organization relationship. So if you're only training on the material of architecture, you're basically just making a machine that's good at automating the production of pre-existing architectural forms and spaces.
Right, so that takes us a little bit to your work, as you describe it to me at least. It's looking into automated design systems, right? Artificial intelligence and repositioning the authorship, right? Like, what is your view then on automation, right? Because one would argue that, or perhaps the way we've been engaging machine learning is that it has a potential, a great potential of understanding automation, one that perhaps reminiscent of, I would say, the non-standard, one that could potentially kind of be far more adaptable than current versions of automation as we've seen them in the world.
Sorry, I'm not sure I understand the question.
I'm wondering if your version of automation or your pursuit of research in automation points to a future of architecture that can maintain a radical adaptability or radical kind of transformation while performing such automation, and not perhaps default on almost. I read it as a kind of an even more accentuated version of the non-standard, one that is kind of fully capable to be driven by these algorithmic intelligences.
Yeah, I mean, I think that's the aim. I think that there's a lot of moments though, as we're working with especially some of the systems that are getting more convoluted towards the production of physical architecture, like the ones that were trained for the house or the Talon Pavilion, the house being this guy that was towards the end. There's moments of it, there's things that we quite like about what we're able to get from this. This isn't the kind of final plan, but it's my favorite plan from this house, because it kind of represents a lot of things that we're trying to pursue through these systems. At a certain level, it performs spatially. At another level, it kind of defies analysis from a history theory point of view. So it does succeed at the planner level from breaking from the kind of trap of just revisiting past hierarchies and past diagrams for architecture. But as soon as we get into the section and elevation, the kind of effort that we had to put into the 3D network to produce the spaces that would perform appropriately in the structure, the structure becomes incredibly hierarchical and reinforcing those pre-existing conditions. So there's quite a bit of momentum and kind of weight that these systems can start to build up that makes them difficult to steer. If you look at the kind of representative energy that's consumed in the production of a machine and the training of the machine, like there's a certain cost to continuously adapting it, right? And so that's definitely something that we are critical of our current processes and the current processes that are out there, but it's basically the task that we're looking to approach.
Right.
Again, by specifically undermining a lot of our precepts or about the way things ought to be understood in terms of information architecture and what's valuable there.
So I remember hearing from you that you're moving forward from materializing some of these models. And could you tell us also a little bit about the research that you're doing on? I think that you're collaborating with Mimi Zeiger, right? And the study of incremental housing models or transitional housing. Is that something? How do you tie that with the tools that you've developed over the years?
Yeah, I probably should have brought some images of that stuff. So Mimi and I have been doing a series of courses together at SCI-Arc over the last 2 years, like looking specifically at like how we can use machine learning to understand housing conditions in Los Angeles, or come up with kind of different proposals for that. This is from last year, which 2 years ago, which is very different than the more recent course, but I don't have the site up yet for the more recent course, which was much more, we made the decision to just not do any design, like architectural design work in the current version of the course, because it's SCI-Arc, it's like as soon as you give the students a chance to do that, that's like where the focus goes. So we're really looking at how we can begin to, again, like our interest with the machine learning stuff in particular is how it can expose patterns or relationships and systems that are maybe hidden to us. So some of the work we're looking at are trying to find like alternative data sources for understanding housing conditions in Los Angeles. There's another project that I'm kind of helping out with occasionally that's looking at specifically like eviction events, and this is a case where there isn't publicly available information that gives an accurate representation of what's driving evictions, where evictions are occurring in the greatest quantity in the city of Los Angeles. So the idea is like, can we begin to use networks to look at how to create correlations between, let's say, parallel or other factors that could be driving these events. So that, again, this kind of idea, we're kind of constantly like looking at like how to flatten different domains of information together. You know, that stuff translates very directly into the, some of it very directly into the kind of prototyping of ADU scale architecture, which we're doing, which is, I don't have images to show that yet. That's kind of the main focus of this summer. But we're going to begin to prototype something based on a structural system similar to this, but the new improved version that is going to be looking at using networks, like using kind of smart contract ideas or ideas derived from that to think through incremental housing models in LA. So basically, we have a kind of whole hierarchy of systems, from putting out cores, an excess of cores on a site for collective housing, kind of heavier structural systems, so that over time it's easy to adapt to and attach to as people's economic systems change over time. That's all very kind of nebulous right now, because I don't have anything to show you specifically for that. But the dialogue there is it's really the kind of same problem, like no matter what medium you're in, it's the information you're getting, or the data that you're getting isn't information, right? And that you need to figure out how to turn it into information, whether that's translating structural and spatial information and then budget information into a form, or identifying sites within the city of Los Angeles that are maybe overstressed or understressed, or could be targets for revenue influx from different investments.
Right. I mean, I wish we had more time to dig deeper into that. I'm fascinated of how do you kind of navigate this notion of incremental housing that might have, it might change regimes of authority or governance that might take place on the process, while also kind of coordinating a technological infrastructure. But I wanted to ask you specifically about the discrete project, which is something that we haven't discussed, and certainly you and I, and obviously certainly like many other people in the world, have been putting forward as a proposition. And what it's always struck me is that the discrete project is indeed a very diverse project that has kind of different perspectives from the different participants. Could you share with us a little bit of your own take on how you're connecting your computational methods or your material methods in regards to the discrete agenda, and what perhaps where is your own departure as well?
Well, I think from the start, the conversation has always been about this efficiency between computation and material at a certain level. And it goes through many different trajectories. Like Daniel Kohler working at kind of these massive urban scale structures, trying to thinking about kind of program as part, right? Program as mereological element. And I think in our case, it's a very literal part as part, and program as well. But it is about this kind of repositioning of the investment of labor and intellectual work in kind of the software and the platform side, the side that like organizes the materials, organizes the economics of the project, organizes the kind of forms of the project in response to those things, through and then operating using basically in our case getting the complexities that we're interested in about creating these kind of new types of architectural environments and spaces through that organizing platform, not in the material production. So like the facility we're putting in to produce these prototypes that I mentioned, like where they're essentially pick and place robots, right? Which is a very fast construction system for a robot, working with very low grade timbers. So we're also, extremely low grade timbers, like timbers that you wouldn't typically be allowed to use in a structural platform or a structural partition. So like the idea being that we can basically more efficiently use lower cost materials because we're investing more effort and time in the development of the platform, rather than having a kind of formally sophisticated platform that is then requiring a massively expensive, energy consumptive and energy intensive and economically intensive fabrication process like 3D printing or 3D printing is probably the big. I think all of us touched 3D printing at some point and we're like, whoa, this is really slow. Like this is really expensive, really slow. This is not a scalable technology at the moment. Although I think there's some stuff that is getting closer to that, especially when you get into kind of bioconcretes, that sort of thing. But the idea that we should be, looking at how we can use these platforms to make complex or interesting architecture or innovation within architectural form and space more equitable, right? Or more affordable. Not everything gets there. Like this thing here is that we're looking at, like Yasushi and I were using it as a way of testing specific details that we're interested in, how to connect the panels, but it's a fairly excessive in terms of its material. But this thing is the kind of system that we're translating into the ADU, where we're going to be able to work with low-grade timbers, thinning timbers, which also kind of works in the whole kind of climate cycle. Again, this idea that the platforms need to engage multiple scales of information and data. So we're going to be funded by U.S. Forestry Service to do these prototypes, and one of the things that we're targeting with it is being able to integrate low-grade timbers from thinnings that can help subsidize and incentivize behaviors which mediate forest fires in California, which is a big issue here, right? So I think it's about, on the one hand, like a robot is like a pretty expensive investment. On the other hand, if you look at kind of the cost of it against the scale of production it can achieve, it's actually, pretty reasonable, and it can rapidly produce these panels. So yeah, I think that's kind of the fundamental idea of the direction. Like we've always treated data as part is part, space is part, and the form being a kind of accumulation between the relationships between all those entities.
That's great. Thank you so much. I mean, Casey, we're running out of time. So I think I want to thank everybody that has joined us in this interview today. And I want to thank the Architectural Informatics Society for having myself and Casey here today. So I want to pass it on for Casey to announce what is going to be the next person to interview.
Yes, on July 8th, I'll be interviewing Yasushi Yoshida, who collaborates with me at our studio, Yoshida Rehm Studio, but has a kind of long career looking at engaging with advanced software technology and parametric software and production of really advanced architectural systems from offices like Morphosis. We worked on the Broad Museum with Gensler and also with Satoshi Abe's office.
Yeah, so thank you, and thanks for having us. All the best. Bye.
Thanks.